Ladies and gentlemen, dear colleagues, dear friends, I would like to warmly welcome you to the update on new Bruker products on our Bruker Now platform. My name is Wokrina. I am the Market Product Manager for the MRI products at Bruker Preclinical Imaging. And I'm here together with Michael Heidenreich, who's the head of the nuclear molecular imaging business. He will give you insights into new NMI products later. I would like to start off with a few new insights and exciting developments in the ultra-high field regime, and then also give you an insight into new products on software. But let's start with the ultra-high field. We're always on the hunt for higher sensitivity, and it's basically a journey from sea to summit. Sensitivity is characterized by the so-called signal-to-noise ratio, or S/N, signal over noise. And it is needed to generate all these beautiful images and spectra that we know and that we need to do our science. And it can be improved, of course, by two means, either by reducing the noise using cryogenically cooled coils. They're called cryocoils or cryoprobes at Bruker. And this works perfectly because they generate a sensitivity gain of a factor of 2 to 5, depending on the frequency, which can in turn be translated into higher resolution. At the same time, you can, of course, also apply higher fields and go to ultra-high fields. And this is also something that works perfectly. On the next slide, I show you an example that has been generated by researchers of the Weizmann Institute. They compared an olfactory bulb measurement in a mouse at 7 Tesla and at 15.2 Tesla with two coils which are comparable. And they actually found in this olfactory bulb a signal increase of a factor of 4.2. which would correspond to field change proportional to the power of 1.85. So it's clearly a supralinear behavior. It's not linear with the field, as one could potentially expect. It's almost quadratic. So there's a significant gain, which you can then invest in higher resolution. And this higher resolution also pays off in a better contrast, because since the resolution better matches now the anatomical structures, there are less partial volume effects, which in turn give you a better contrast also. So this works perfectly, and we have a higher sensitivity at ultra-high field. This is always good. But I would like to raise the question, is this sufficient to drive the field of MRI forward? Is this sufficient to drive ultra-high field? Is it simply sensitivity that we need? And I would like to invite you to discuss with us and chat with us, what is it actually, what drives the applications at ultra-high field? And there are quite a few effects that benefit from ultra-high fields beyond the pure sensitivity gain. And this is shown on the next slide. There are various effects, like the so-called bold effect, which is used for bold fMRI experiments to measure brain function. This effect also scales with the field strength. It's not only the sensitivity, also the effect becomes greater. Same with the spectral splitting in spectroscopy, which you use for metabolite imaging, but also in chemical exchange saturation transfer experiments, or Zest. And also susceptibility effects, they increase at ultra-high fields, which you can in turn use then to do microstructural investigations of tissue, investigating electrical properties also of the tissue. So there's a lot which goes clearly beyond the pure sensitivity gain of ultra-high fields. And we summarized a few of these ideas on our website, which you can see at the bottom under bruker.com, products MR, why use ultra-high field? And I invite you to discuss with us what actually would benefit from ultra-high fields. I would now like to give you two beautiful examples that clearly benefit from the ultra-high field beyond the pure sensitivity gain. And the first example is this beautiful example from Neurospin in Paris and researchers from the Weizmann Institute, which applied glucose Zest in rat brain. They used ultra-high fields of 17.2 Tesla to do this. Actually, the most commonly used method to measure brain function is bold fMRI, as I just pointed out. But the bold effect is only indirectly coupled to neuronal activity, to the vascular response function. However, glucose consumption itself is more closely coupled to the neuronal activity. For that reason, the researchers from Neurospin and Weizmann Institute have suggested this glucose Zest or glucose Zest experiment to measure transient glucose change upon neuronal activation that go along with the bold effect. And actually, what they found, you can see on the right-hand side. So along with the positive bold effect, they found transient glucose Zest changes in the same regions of the brain where they found the activation. But as I said, this is more specific to neuronal activation than the bold effect, which is due to vascular coupling. So in this rat model of electrical four-pore stimulation, they could establish a new means of measuring brain function more specific than we can do right now. And it was only possible because they used ultra-high fields of 17.2 Tesla. Because of the higher splitting, spectral splitting, higher spectral separation that results out of it, and the higher sensitivity, they were able to establish this new method. There's also a good potential to translate this into humans in future because it is simply using an endogenous contrast mechanism using the glucose which is consumed in the brain, which is always there. The other example I would like to show you is deuterium metabolic imaging, or DMI, which was also applied here at ultra-high fields of 11.7 Tesla. And it was done by researchers from the Yale University. The most commonly used method to monitor metabolism during tumor progression is FDG-PET, positron emission tomography. And Michael will tell you later more about PET and PET-MR. However, whereas FDG-PET is a highly sensitive method and it can detect tumors and lesions throughout the body, it is unspecific to the glucose metabolism. So it will only indicate the glucose uptake and consumption, but not reveal the whole metabolism. For that reason, the researchers from Yale University have suggested this DMI experiment in a rat brain glioma model where they administered deuterium-labeled glucose into the body. And they quantified then the lactate over GLX ratio. So GLX stands for glutamate and glutamine, which in effect represents the so-called Warburg effect, which is characterized by the high glycolysis and low oxidative metabolism in the tumor. It's a well-known effect. But for the very first time, they were not only able to measure the downstream metabolism, but also even image this Warburg effect. So the bottom right image exactly shows this ratio lactate over GLX, and you can clearly see the core of the tumor. Also here, the ultra-high field of 11.7 Tesla helped with its increased spectral separation and higher sensitivity to establish this novel method, which can now also be applied into humans. And there's a good potential to translate this because it works even without the administration of radioactive traces. And it has even been demonstrated by the researchers from Yale because they applied it in humans in a 4 Tesla system. And here it worked perfectly. What is our contribution to the field of ultra-high field as a vendor of preclinical machines? Well, we can supply you the tools, the solutions to do the science. And we clearly recognized a need for even larger samples for ultra-high field MRI measurements and also for even higher fields than we offer today. For that reason, we plan to extend our portfolio in the ultra-high field regime with 3 new magnets. So currently we have 2 magnets available at 11.7 and higher. This is the 11.7 Tesla 16 centimeter and the 15.2 Tesla 11 centimeter. In addition to that, we now will introduce 3 new magnets, an 11.7 22 centimeter, which will accommodate very large samples, for example, marmosets, and make that now accessible for measurements in ultra-high field. In addition, we will introduce the 15.2 Tesla 17 centimeter. And then the ultimate will be the 18 Tesla 11 centimeter magnet, which will represent the highest field horizontal bore MRI machine in the world. We have an installed base of more than 40 ultra-high field systems, 11.7 Tesla or higher in the field, which do drive new discoveries every day. This is great, and we want to support it even further. We think there is much more room to gain and new insights to gain to drive new discoveries. This is why we introduced these new magnets, which will then make use of Bruker ultra-high field technology and ultra-shielded and refrigerated or USR magnets, which are zero boil-off. These magnets will stay at field for a week or longer, even if there is a cooling disruption. So this will give you the most stable performance. It is very important for us, I pointed it out, we have also cryoprobes as a means to boost the sensitivity. And of course, it is a goal to combine also these new magnets with the sensitivity boost of the cryoprobes to enhance the sensitivity even further. We have actually sold one of these 18 Tesla 11 centimeter magnets and systems already at the end of 2018. To Dr. Nouam Shemesh. He's the director of the Preclinical MRI Center at the Champalimaud Center for the Unknown in Lisbon, Portugal. And you see a photo of this beautiful institute to the right. And he's, of course, excited to explore the potential of this 80 Tesla MRI machine. But what's noteworthy is he also wants to advance the understanding of biological mechanisms that underlie healthy and disease conditions. In his case, he wants to investigate brain and tumors. And I can only second when he says it is very important that this will also help highlighting MRI as a tool for answering fundamental questions in biology. So we need to go beyond beautiful images and highly resolved images. We need to answer fundamental biological questions. And I think ultra-high fields open up new avenues to drive these new discoveries. I would now like to give you an insight where we are with this first order of an 18 Tesla MRI system. And this is a little video which just shows what we are doing in our magnet factory. These are shots taken as of last week in magnet factory. The first section is ready. Impregnation is finished. The innermost section. Section 2, we finished the jointing. Section 3 is currently in the impregnation bath. This is a top view of this impregnation bath. And the outer sections are wound and ready for jointing. This means this magnet is now materializing. The most important ingredients are there. They are manufactured, all the coil sections. Now the magnet needs to be assembled and put into function. And we do plan to bring this magnet into the field by next year. I would now like to switch gears and announce 2 exciting new software products. For Paravision 360, which is the most advanced software for preclinical imaging research. This slide shows our roadmap for our Paravision development. And as you can see, we have 2 active software trees running in parallel. One is the Paravision 6 and 7, which supports MRI-only configurations with OWASP 2, 3, and 3 HD electronics versions. In parallel, we established the Paravision 360 software tree for state-of-the-art Avance Neo MRI-only configurations, as well as for multimodal PET-MR and PET-CT configurations. As you can see, we've had a version 2 release, and I will go into a few details and highlights of this version 2 release. And we're also close to a version 3 release, so I will also give you a sneak preview into the new features. I will focus now on the MRI features only, because Michael will dig a little bit deeper into the improvements on the nuclear molecular imaging side. One of the highlights of Paravision 360 version 2 is dynamically shimmed multi-slice CSI, which we introduced with this version. What does dynamic shimming mean? Dynamic shimming means the homogeneity, field homogeneity, is optimized for each of the slices of the CSI chemical shift imaging experiment, which gives us in turn a much narrower line width. And then when the slice is advanced, the shim is also advanced transiently. The scanner does that for you. And the effect is a great one. In the spectrum to the bottom left, this is a highly resolved spectrum. You don't see much of a difference. So we need to look a little bit more into the details of what the dynamic shimming brings us. And this you can see in the two spectra in the middle. The blue curve shows the normal shimmed multi-slice CSI, and the red curve shows the dynamically shimmed CSI. And as you can see, for example, with the NAA peak, is that the peak sensitivity greatly increases due to the reduced line width of the peak because of the much better homogeneity within the slice. It should be noted that we can increase this peak sensitivity without even increasing the sensitivity overall. So without applying cryoprobes or so, only because of the shimming, the peak sensitivity increases. In addition, we can now also separate, for example, the phosphocreatine and creatine peaks, which is not feasible without the dynamic shimming. They overlap so much that you cannot separate them and quantify them. So overall, we have an increased spectral resolution and a higher peak sensitivity, which allows you to quantify more metabolites and quantify them even more precisely. I think that's a great step forward in metabolic imaging using MRI. Here are some of the highlights of version 2 summarized. We also introduce online or real-time decisions with version 2. Multi-slice CSI with dynamic shimming I have mentioned already. We also introduce a new improved operation mode handling for X nuclei. When you store a protocol for a given nucleus, it will be saved. And when you recall this protocol with the proper coil plugged in, it will then appear with the right nucleus setup. This was a bit confusing in the past to our customers, so we listened to you and changed this behavior. And we have numerous other improvements, such as the so-called preferred initial image orientation. You can now set your preferred image orientation, for example, radiological or preclinical convention, and the system will take it then as you like it. This update is free of charge, and you can simply download it from our web server under Bruker.com, service and support pages, software downloads. You need to register for this download, but all your existing licenses remain valid. So I can only encourage you to download it and try it out. I would now like to give you a preview into version 3, which is to come soon. There are 3 major areas of improvement for MRI specifically. First of all, we had a big focus on enhancing the productivity with your scanner by introducing new acceleration schemes. One of them is compressed sensing, which allows you to safely accelerate your images by a factor of 2 or even more. Compressed sensing is a work-in-progress package, and it's not available for use in the US at the moment. In addition, we also introduced 3D grappa, which allows you to accelerate your 3D images. Overall, with these new acceleration schemes, you will get your high-resolution images much faster. So I think that's a big step forward here. The second main area of improvement is in X-nucleus spectroscopy and imaging handling by introducing a new auto-adjustment procedure for the reference power of the X-nuclei. And the third area is knowing the health of the MRI. We will soon introduce a new magnet monitoring unit, BMU5, into the field, and new Paravision 360 version 3 can display then the health status of the magnet. This is essential for you as a principal investigator. You would like to know what is the health of the most valuable component of your MRI system. It should be noted that this BMU5 can also be connected to a Labscape services, remote monitoring and alarming option. So please reach out to our service department to discuss the details. The release of this new software is scheduled for this quarter 3, 2020, so very soon. I would like to show you a few more details about this new compressed sensing feature. The top left image shows the fully sampled image. If you would simply undersample the image by 50% by leaving out half the k-space lines and zero fill the rest, you would get a severely blurred image. And this you see to the top right. It's basically an unusable image. You can apply elliptical encoding, which will give you decent quality with a slide acceleration of about 1.3. But now, when switching on compressed sensing, you can safely accelerate by a factor of 2 or even more without the artifacts you would have had with the zero filling option. So I think this is a great improvement, and this will greatly enhance your productivity with the system. This compressed sensing scheme is available in all standard methods, including intragate, flash, and UTE methods, where it is an intrinsic or polar undersampling. And it's as simple as clicking on compressed sensing to activate it on the encoding card. For the experts, we make all the reconstruction parameters available to you, but you don't have to access them if you don't need to. Last but not least, I would like to give you a few more details of this new X-Nucleus reference power auto adjustment. So it's an automatic procedure which allows you to set up the pulse length or pulse power, and a report is automatically generated that lets you review the outcomes of this adjustment procedure later. You can set it up to look for the maximum or zero crossing, or even have multiple cycles if you wish to. And we think this is a tool which will make X-Nucleus spectroscopy and imaging much more accessible to a wider range of researchers. And we hope to see more examples like this beautiful one you see to the right, which is a fluorine-detected arthritis model from the University of Düsseldorf. This was generated with a manual setup procedure, but as I said, we hope to see more of such beautiful examples in the future by a wider range of researchers. This was it from my side. I would now like to hand over to Michael, who will introduce new products and make new announcements for the nuclear molecular imaging. Michael, over to you.
Thank you very much, Tim. Hello and welcome from my side. It's a pleasure actually for me to present you the news on nuclear molecular imaging. So since we are now on the ISMRM, I will focus mainly on the news on the combination of PET with MRI. If we take the opportunity of these events to have a look back, we will immediately realize that already in 2008 we started with the first PET-MR products at Bruker. So at the time we developed the first PET insert together with Bernd Pichler's group from Tübingen. And the nice thing about this is the installed devices from that time, they are still operable and they are still producing scientific results that are really significant for conferences like we have it today. Now in 2016 we decided to introduce the second generation of PET-MR products. The PET insert was introduced at the time. This time it's based on a different technology, and I will come back to the technology in a little moment. What we immediately realized is that there was a great interest in these products. So the customer base really increased significantly in over a very short time. Many of you have decided to go for one or the other combination, either PET-MR simultaneously, that's an insert, or for the sequential setup. And with this increased number of installation sites, also the range of application that was done with these inserts has significantly increased. When we met then last year on the ISMRM in Montreal, it was a real pleasure for us to announce that the colleagues from Pmod have joined Bruker. And we are really happy about that, because we think with the Pmod software, we can provide you the best possible solution for total PET quantitative data evaluation and for kinetic modeling of your kinetic studies. Now this year, it's a pleasure to talk about news in the core elements of our PET-MR business. So we will see news in terms of PET technology, we will see news in terms of software, either on the Paravision side or on the Pmod side. And it's also a pleasure to talk about a new product that was introduced this year, and this is the small PET insert, so this will also be part of this presentation. If we start with Paravision, Tim already mentioned the nice features of the main multimodal software platform. He also talked about the great success and improvements in terms of 3D image acceleration, which actually I think is very nice because, you know, in PET-MR, when you acquire attenuation maps, you want to be fast, and that can be an essential tool to achieve this requirement. Okay. Now, I'm going to focus a little bit more on the PET-MR and the NMI pieces. You have maybe already realized that Paravision 360 version 2 is available, and in there we have included now inside of the image sequence analysis tools the features to make time activity curves or do a direct PAT-lag simulation of your kinetic experiment. Also very nice is that we combined and integrated here for the first time the integrate PET-MR. So for cardiac applications, you can use the MRI integrate signal to define triggers for the reconstruction of PET data without the need of any electrodes or respiration pads. Now for Paravision 360 version 3, which is about to be released, there are very nice new features because during the last 2 years we concentrated a lot to improve the image reconstruction features of our PET data. Actually, we concentrated on 3 factors, which is speed, signal to noise, and then contrast and resolution. If we look at the speed, we have now available the OSM image reconstruction algorithm. So instead of reconstructing the entire data set in multiple iterations, we can split up the data set into certain subsets and then do the processing in parallel. We need less iterations, and that just means we are faster. In order to give you an example on what that really means, here's a typical experiment. Let's say from a mouse, we acquire PET data for about 20 minutes, which results in PET data sizes in the order of 8 to 10 gigabytes. And then depending on the reconstruction features that you add to the reconstruction, we see that we can obtain up to a 3 times faster image reconstruction. And the good news about that is there's no compromise in anything like image quality or artifact level of the images. If we think about how to reduce signal to noise, MAP is known to be a method that is able to suppress the noise level by the introduction of so-called regularization parameters. When you select higher values for these regularization parameters, you suppress the noise. And you have a nice example actually on the slide deck. When you go to the higher values, you see how the noise goes down and how the structures show up more crisp and more better defined. But that's not all. On top of that, we introduced 2 new reconstruction features. One is the simulated single scatter correction that is using attenuation map information to derive a model for the scatter, for the single scatters. So we include this in the reconstruction in order to avoid any background signals. And then on top of that, you have an invariant point spread function that you can add. And if you put both together, you see that even for the very small structures, resolution becomes really good. That's also represented by the recovery coefficients that are very close to 1, even for the very small structures. If we put all of this together, let's start with an MLAM reconstruction, add the map, point spread function, partial volume correction, and the PSF and the PVC. At the end, we have very, very nice images, very good signal to noise, with a crisp contrast and very clear definition of structures. That's actually an example that we developed together with customers from a 9.4 PET-MR installation in the US in Indianapolis. Okay, we had a very nice webinar for those of you who want to learn more about this. The webinar is still available. We hold this webinar about almost 1.5 months ago or 2 months ago now with 2 experts in the field. One of them is Harry Zumpers from the University of Leeds, and the other one is our PET image reconstruction expert from our Valencia reconstruction team. If you're interested, just go to the Bruker page, Google for the webinar and you can reload it and rewatch it again. Now let's talk about Pmod and the news there. There will be a new version, which is then the version 4.2, available towards October of this year. And this new version has two main new software packages. The first new software package is the Neuro tool for rodents. Some of you may know this already from the human applications, so the exact same tool has been now translated into the rodent domain. And you can use templates that you register either on an MRI or a CT data set, and then with the use of this special template, you can easily do the PET quantification, the quantification of your PET data. Another very nice new package is a framework that we provide here for the use of artificial intelligence or neural networks for image segmentation. Okay? So you can select your network that you want to use, train it with processed data sets, and once it's trained, you can use in the trained network and apply it for the image segmentation of new data. On the slide deck, you see an example where we used about 300 data sets from human application to train the network, and then apply the trained network to new data sets, which is very efficient to do the right segmentation with a high precision. Pmod will also be offering you a new licensing option, and that is that you can select a cloud license, which is very nice and very important, maybe especially those days when you have to work from everywhere. So once you have selected to go with this license feature, you can just download the license from wherever you are. Okay, now let's talk about a new product, which you also find here. In the slang, we also say it's a small insert. And actually, you see here, this is a detector block, and this is the electronics cabinet. And it's a small insert because it's used in the smaller bore magnets. So this could be a 3 Tesla magnet, it could be a 7 Tesla 20, or a 9.4 Tesla 20 centimeter system. If you have larger bore instruments, let's say a 7 Tesla 30, you can either use the large insert, or you can use the small insert, as it is here, as long as you have a BGA12 gradient insert available on your scanner. So that can also be used at 7 or 9.4 Tesla. And if you're a former Agilent or Varian user, don't hesitate to ask us. We will find solutions to make this insert available also on your instrument. If we talk about dimensions, you see here the outer dimension of the insert is 103 millimeters. The inner dimension is 60 millimeters. And in terms of field of view, the insert provides you a field of view in the axial dimension of about 40 millimeter in diameter and up to 101 millimeter in length. If you translate that into application fields, you easily see that this is perfectly suited for mouse application. So mouse body application is fine, mouse head application is fine, but you can also think about using the insert together with the corresponding RF coils for head applications on small rats. The mouse body application coils are all already developed, so they are there. They are PET optimized coils. The PET optimized coils for the mouse and for the rat head applications, so the specific neuro coil applications, they are in the development pipeline, and we will report about it as soon as they are validated and available. The PET insert itself can be configured in 3 different ways. Yeah? You can have a 1-ring, a 2-ring, or a 3-ring configuration, and the choice of the right configuration depends on your application on the one hand side, and on the other side on the sensitivity that you want to have. Okay? If you think about mouse body application or rat head applications, we would probably suggest to go with a 3-ring configuration. If you are interested in only parts of the body like cardiac or only mouse brain, a 1-ring configuration could do the job, but always at the price of lower sensitivity. Actually, the PET insert is designed and is using the same technology as we also use it in all of our other PET products. So in this case here, we are using larger crystals, and then on the surface of the crystals, there's an array of silicon PM to read out. And once you have an event in the crystal, the light will generate some kind of a light distribution on the surface, we read it, and if we read it out, we exactly know where in the crystal the light event has taken place. Okay? So in this way, we exactly know the line of response from the beginning to the end. There's no doubt about, no assumption about where the line of response is. And in this way, we don't have any kind of a parallax error that you know from the pixelated crystal designs. And that has a real impact in the quality of the results that you can obtain, especially if you think about large objects or multiple mice that are in the scanner at the same time. Imagine you have a sample sitting in the center with any of the configuration. This will work fine. It will give you the right position and the right distribution of your signal. If you go outside without a full depth of interaction correction as we have it here, you would see that not only the position is wrong, but also the shape of your signal is wrong. That's not the case in our setup, so we know exactly the position, we know exactly the size, and therefore we don't do any errors in the quantification wherever your object is located in the scanner. So for the new pad insert, one of the first things that we verified was actually that this works also correctly in the smaller setup here. And you see on the top right of the slide the experiment where we turned the depth of interaction on, and you see wherever you are in the sample, the point source remains a point source. Yeah? If we turn it off in the middle, the point source is still a point source, but if you go outside, it gets something but not a point source. Equally important for a pad insert is that there is no interference between the pad and the MRI measurement. In order to verify that we avoid such interferences, we take the pad insert outside of the MRI scanner, we acquire a flood map, and then we insert it. We start a very strong EPI sequence, for instance, acquire again a flood map, and then we compare that there is no difference between the flood maps between the two different situations. And actually, this is what we did here. There's no difference. Upon many other tests that we did, we can definitely conclude that there is no interference between the two devices. Next step is to look at the image quality. And what you see on the slide here is a Lorenzo phantom with rods down to 0.7 millimeters. If you look at the 0.8 millimeter rods, they are perfectly well resolved, really perfect. And if you go to the 0.7 and look carefully, you even see that even the 0.7 millimeter rods can be clearly identified. Homogeneity is in the order of 5%. This is very typical for our products. Then the initial NEMA characterization yielded us spatial resolution below a millimeter for the entire field of view, sensitivity 11%, a bit higher even, and then the mouse count rates are in the order of 450 kilocounts per second. We also checked, obviously, the quantification, which is for different nuclei always below the 5% in a typical range of activities that you may have in the scanner. And here you see a couple of images from the first installation. If we start on the right-hand side, we see three smiling people. Most important in the background, our customer, the young lady. She's very happy that she has received the insert and that we can install and run through all the acceptance tests successfully. And then in the front, it's Emilio, our service engineer, who did this first installation. So he's happy because everything went smooth. And since we can always learn something new for the first installations, also our main R&D person, Carlos Correche, attended here the installation, so he could assist and see that his product has made it finally into the field. On the left-hand side, you see how it looks in reality behind a magnet. Okay, you start with the pad insert, it's sitting on the trolley in a very safe manner. You go behind the magnet, open the door, you slide in the pad insert by the use of this little table, and then there's a mechanical fixation that keeps the pad insert always in the right position. Okay, and then if you look from the front, the RF coil is inserted in the pad insert sits in the gradient set, and the entire setup is ready to accept the samples, so the animals. Now we are going to start to quote this device in September because we want to finalize a few things before we go into the free quoting process. So we will scale up production, do all the certification, documentation correctly, go on in the internal and external validation. There will be actually a second beta testing site. And then we also want to provide you with a full NEMA characterization very soon. Normally at this point in the presentation, I would go over and show you also the nice applications that you can do. We are a little bit limited in time, so I would like to refer to a second webinar that we did in June of this year. Actually, this was a webinar that was mainly done by Peter Paravision and his team from the Martino Center at the MGA at Harvard. And he really talked about so many applications. It was really nice to listen. So starting from neuro application using carbon-11, liver imaging with manganese, Deuterium-based tracer that simulates the deposition of gadolinium in the body, multi-mouse imaging. They are actually doing a lot of tracer development. So they started with 2 mice, and then they went to 3 mice, and now they are at the 6 mice, and the bed can have up to 8 mice. That's really nice to see how they scaled it up. They have the head-to-head position of red imaging, and they are also using, obviously, other nuclei for the experiments. One of the nice things that I realized in this webinar is to see how there are synergies from the PET side to the MRI side and back. So they are using, for instance, they have an MRI question, okay, how does a certain MRI tracer, for instance, behave in vivo? They use the PET to investigate this, and during the investigation they see that using the MRI information can yield better PET results, and at the end all of these results go back to the MRI. It's really nice to see it's more than just 2 modalities, it's synergetic, yes? The sum of the 2 is more than just 2. And another interesting message that actually Peter gave me on a private notice was when he explained to me how he used it. He said, Michael, look, it's really interesting since we have this PET device, this hybrid imaging device in our lab, we are getting really a lot of interest from many, many groups, okay? They have many new projects coming in, and with the projects they also get obviously funding for these projects. And the best thing about this is because you have this new hybrid PET-MR, new science is enabled. Another area where to find nice application examples is definitely the ISMRM. There is a number of abstracts on the ISMRM, and it's very interesting to listen to these talks to see how other groups are using these new PET-MR devices. If you're interested, go to the ISMRM online talks and listen to them. We offer you to come out to our live video meetings here, have discussions with the Bruker staff, join our lab tours, win a prize, mouse to the house. You can check out our online training courses, webinars, and if you want to stay informed, just subscribe to our newsletter. So I would like to wish you to enjoy the ISMRM, and from my perspective, obviously enjoy it with PET-MR. Thank you.
Thank you very much, Michael, for these wonderful product introductions and all the exciting announcements on the nuclear molecular imaging side. We're now coming to the questions and answers session of today's broadcast. And if you would like to submit questions, please enter them into the Q&A panel, which you will find at the bottom of your screen. I see that a few people have already attended one of our broadcasts and did so, but please enter also more questions into this Q&A panel. And now we have Wolf and Guillaume with us, and together with Michael and me, we will try to answer all the questions that are coming in.
Thanks, Tim. Thanks, Tim. Let's see what came in.
All right. So, first question I think goes to Michael. Do I need to recalibrate the PET for Paravision 360 version 2 or 3?
Well, actually, thanks for this question, actually. I should have mentioned that maybe. Because we have this new PET reconstruction features included, yes, you have to do a slight recalibration of your scanner. So we are repeating the normalization of the PET detector. The good news about this is we can help you remotely to do that. So a service engineer will log onto your system, will instruct you what to do, and then we calculate the new calibration and play it back onto your scanner.
Okay, thank you very much. I think there's one question which we should direct to Guillaume, and that is actually, what field strength sells the most?
Okay, well, that's a great question. Actually, that's an interesting question, and actually, we do see some changes in that area. And in the last 2 years, there's been an evolution. For many years, I think the bulk of our sales was really at 7 Tesla, to be fair. And we really had high volume of units sold at 7 Tesla. And in the last 2 years, we've seen a shift actually towards 9.4 Tesla. And today, definitely the highest number of systems we're selling are at 9.4 Tesla. I think one reason for that is obviously the gain in signal to noise, the higher resolution, there's no question. But also, I think a lot of labs are already equipped at 7 Tesla. And so they're looking for an upgrade. They're looking for pushing the science even further. And for that, they need higher field. And I think today we're definitely the only company with a track record, a proven track record of successful installation at 9.4 Tesla. We're very proud of that.
Thank you, Guillaume. All right, I think the next question is for me. Can you measure rats in the 18 Tesla? Yes, you can. I explained to you earlier that this 18 Tesla system will have an 11 centimeter bore. And this features a 6 centimeter gradient, which will allow you to put small rats into this system. So we will allow rat head and brain measurements with this 18 Tesla, of course, along with all the mouse measurements. Okay. So, next question again, I think it's Guillaume. Sorry. If I would need an in-depth discussion and a quote from Bruker, how would you do that in times of COVID-19?
Well, I think we are really facilitating this as much as possible by trying to reinvent ourselves constantly in creating ways of communicating with our customers in the most personalized manner. So we're actually very available to take video conference, phone calls. We, of course, email is a very basic one. We suffer a lot from not being able to travel. That's our modus operandi. Typically, we would go to customer sites almost all the time and meet with them. Nowadays, it's a lot via video conference. Actually, just before coming in here, I was on a video call with a customer in the United States. We were seeing each other. It really felt like we were sitting together. So the only thing we couldn't do is, share a coffee or tap ourselves in the back. But obviously, it still felt very real and very useful interaction. So if you want to have an in-depth discussion with a Bruker staff, no matter what the topic is, actually during ISMRM, please visit our On24 Hospitality Suite, which you can find. It's very easy. It's bruker.com/now, N-O-W, and you will be able to schedule a personalized meeting with anybody, whether it's application, sales, management, service. It's very easy to use, and you can choose the time you want in a calendar.
Thank you, Guillaume. I think we have a customer here that was watching your keynote introduction, Wolf.
Well,
yeah,
I get a question.
Yeah, to Wolf, it says, we heard about the new Bruker Campus. Can you please explain how this will affect the preclinical imaging customers?
Of course, I'm happy to answer a bit or explain a bit on this question. I'm surprised that typically these keynotes don't get questions, but I am happy to answer that, of course. This campus concept includes a visitor center in this large building I showed on this one photo. And that visitor center will exhibit basically all the products we have, or most of the products. All is sometimes a bit too much, but certainly the whole variety of products we will have. And so customers can see it, can also, touch it, can even, do some test measurements with most of the systems. They will be up and running. So this will be the visitor center part, and we will have in the building we are here in at the moment, this is the MRI tower, we will have our conference center where we have a number of lecture rooms which are for conferences, for training courses, and so on and so forth. So you will have a lot of exchange between the two sites and between these two possibilities. And then don't forget that the R&D will be concentrated here. So we will have all the R&D experts in close vicinity. So for whatever we need to bring to you or you want to exchange with us, everybody is here and can answer these questions or challenges. So we are very much looking forward to welcoming you in this nice new center we are building here and we will soon be inaugurating.
This is exciting. Thank you, Wolf. There's another MRI question coming in. Can you elaborate more on the real-time decision-making for the new MRI software and a few more details here? What this new real-time feature allows you to do is to rescan case-based lines. For example, in the case of cardiac and respiration-gated measurements, you sometimes miss case-based lines because of motion, and this allows you to safely rescan them while you go. So online, you can decide to restart the measurement of a certain case-based line to be included then in the reconstruction. Okay. Then we have another question that's again MRI. Can I use compressed sensing with an existing MRI? And the answer is yes. Obviously, it needs to be an MRI system that runs under Avance Neo, because this new compressed sensing feature is only available in Paravision 360. This requires an Avance Neo system. But other than that, this new version 3, which will be available soon, this will be also available to your scanner. Currently, we can only make it available outside of the US, however, because of patent issues. We're in the process of resolving this, but until then, we can only make it available as a work-in-progress package outside the US. Okay, then a question to Michael. How easy to use are the new PET reconstruction methods?
Well, there's actually not a big difference between how you used it before and how you use it today. When you set up a protocol, you set the reconstruction parameters and you just select what you want to include, which kind of a reconstruction you want to perform, and which additional reconstructions you want to include in the final image reconstruction. You push the button and then the reconstruction would just start once the measurement is done.
Mm-hmm. Thank you very much. Then there's another MRI question coming up relating to ultra-high fields. You mentioned that cryoprobes can be combined with ultra-high fields, but doesn't the gain drop quickly at high fields? Yes, it's correct that the gain goes down the higher you go in field, but it does not go quickly against a factor of 1, but it's more in the range of 2 for a wider range of field strength. So we know that all the way to 18 Tesla, there will be a very good gain that can be expected from cryoprobes. So we think this will be approximately a factor of 2, which we can expect at 18 Tesla for mice in mouse brain. So this is still a significant improvement in the signal to noise. Okay. A question to Michael. What size or weight of animal fits in the small PET insert?
So the small PET insert has the largest RF coil, offers you 35 millimeter access. That's the access for the animal and for the animal bed. So that works perfectly fine for all sizes of mice. Obviously, if you think in terms of rats, yeah, the rat needs to be placed into a 60 millimeter animal bed to enter the bore of the PET, and then it needs to go into an RF coil which has about 35, maybe 40 millimeter in diameter. So that will be fine for small rats. I don't know exactly the final weight that we can specify, but I think it's in the order of 200 gram rats, maybe a little bit more.
Thank you, Michael. I think we're slowly running out of time, so maybe there's just time for one quick question, and it's again to Guillaume. I will drop you the contact information later. Can I get a quote for the small PET insert today?
Yes, of course, it's possible. I think Michael explained that a little earlier in his talk, that it's not something that we quote as a standard commercial product like we would with a BioSpec 9.4 Tesla, for example, or 7020. But you can have a quote for the small PET insert. Actually, we've sold our first small PET inserts in several countries already, including Norway, Canada, and a few other places. So it's possible. You just need to contact the Bruker sales rep that's in charge of the territory where you're working. Hopefully you already know him or her. If not, just contact us through the website or through the main landline in the office. We'll be very happy to take care of that.
Thank you. I think it's time to close the session because we will have our SBIC Singapore lab to a beginning very soon, in about 5 minutes only. So we need to conclude the session now. Thank you, everybody, for listening.
Thank you very much.
Thank you very much.
Enjoy
Thanks for the
ISMRM.
questions.
Thank you and enjoy ISMRM.